Arnold Ross, a mathematician and educator in the late 1900s, suggested that we think deeply of simple things. He founded the Ross program with this motto. So here's a simple thought. What are the following sums? 1, 1 plus 2, 1 plus 2 plus 3, and so on. When I was young, I used to arrange pennies in triangular arrays like these. So the sums listed count the number of pennies involved. In general, the simple question is what is the sum of the first n positive integers, 1 plus 2 plus 3, and so on, up to n. If you've seen this formula before, it is highly likely that its truth was guaranteed using proof by induction. To prove the theorem by induction, you verify that the statement holds for the base case when n equals 1. Here we check that 1 equals 1 times 1 plus 1, all divided by 2. Next, we assume that the formula holds for some given fixed integer n. And then, we use this assumption to prove that the formula holds for the next integer, n plus 1. We can see that the sum of the first n plus 1 integers is given by the sum of the first n integers plus the extra term n plus 1. Applying our formula induction assumption, we then have a single fraction addition to compute. Obtaining the common denominator, we can add the fractions and then factor out the common n plus 1, showing that the sum of the first n plus 1 integers is in fact n plus 1 times n plus 1 plus 1, all divided by 2 is required. The result then follows by induction. Proof by induction is a wonderful technique. A famous combinatorialist, Herbert Wilf, said induction makes you feel guilty for getting something out of nothing, and it is artificial, but it is one of the greatest ideas of civilization. It definitely guarantees that our formula is true. But another famous combinatorialist, Giancarlo Rota, noted that if we have no idea why a statement is true, we can still prove it by induction. This comment suggests that proof by induction should be our last resort and not our first. Instead, we should seek to understand why the formula is actually true.